Happy Thursday, scholars. This is our last official lesson before we get started in our assessments at the very end of the year. So let's buckle in. We're going to do Unit 9, Chapter 9, A New Day, A New Dinosaur. Wrapping up our unit now with our last chapter today. Tomorrow and Friday, you're going to have your assessment on Edulastic over Unit 9, The Badlands Sleuth. Before we begin, make sure you've submitted Tuesday's race response via text or email. We had a race response on Tuesday. Make sure you get that in. And then have you completed your 5th grade graduation survey? I'm going to put it in the video description again below this. It's in my Tuesday video as well. I put up a separate video about it as well. Ms. Corkins and Ms. Yosef should have talked about it. It's very important to get that graduation survey done, though, before you come to graduation next Saturday, June 6th. That way you have a time slot all picked out, and we're going to share that with you next week. So make sure both of these things are off your to-do list. Our final do now is going to be a kernel sentence expansion. So Jillian admitted. Remember the Jillian from our last chapter? We had the resolution or ending of our mystery, of our crime. We figured out who did it. Julian admitted to what? Where did he admit this? When, so maybe the time, and how. So when you think how Julian admitted, what kind of adverb can we attach to admitted, or what kind of descriptor word can we describe how he admitted doing this? Was he crying and sobbing? Was he acting tough? At the bottom is your expanded sentence where you can combine all these small bits and make sure you have the appropriate periods, commas, and conjunctions so that it all makes sense. Read it back to yourself. Make sure it's not caveman English. Our daily objective for the day, I can explain recycling as a chemical process as it links to the resolution of the plot using perfect verb tenses. So we're going to practice a little bit of verb tenses today. And we're going to talk about recycling as a chemical process. So that might not surprise a lot of you. We put our plastic bottles in the plastic recycling bin, and then that plastic is eventually changed chemically into a new substance. We're going to talk about other chemical processes or chemical changes that we could also count as recycling that you might not think about on a daily basis. Our two new vocab words, photosynthesis is familiar, process by which plants use sunlight to make food from water, and carbon dioxide. So all plants, or rather all plants with green leaves or with a green tint to their color, use photosynthesis. They're collecting that sunlight for food, and then they give off carbon dioxide from it. Or they they take in sunlight and carbon dioxide, and what they release is breathable oxygen. So they take in the bad air and then they purify and cleanse it. Second is juvenile. It's a young creature or person. All of you scholars are juveniles, which means that you're younger people. Your word work below. What kind of plant would not use photosynthesis to survive? So what kind of plant doesn't need sunlight? What kind of plant might you find like under a rock or in like a dark, like gross kind of wet area? Some people like to chop it up and put it on pizza. That's a hint I'm going to give you. And what is a juvenile behavior? So think of what is behavior a young person might have, maybe even a little immature. Take a moment to fill in both of those as complete responses. Before we get started, we have a big question. Why is chemical change the ultimate recycler? And we're going to write a 2-sentence prediction below. I believe chemical change is the ultimate recycler because ... And then I need you to give a reason to back it up. A reason to support this is ... So, give me your opinion why, and then back it up with a piece of evidence or just a belief that you've had or heard before. We're going to take a minute or so to do that before we move on to reading Chapter 9 on page 58. If you have not got out the reader yet, it's in the description below. Scholars, you should have your unit reader open from the video description below. We have a digital copy there. We're going to be on page 58, chapter 9, A New Day, A New Dinosaur. It's the last chapter. Starting at that top paragraph, Amy traced the entire edge of the dinosaur's jawbone with the tip of her finger. She and Matt had finished excavating it, and she enjoyed the feel of the smooth, glossy fossil. A blazing sun hovered over the dig site, but after the success of the morning and the return of the missing fossils, for once the heat didn't bother her. Maybe she was getting used to it. On the other side of the dig site, Tess was showing Felix and Daria how to use a rock hammer and chisel to carefully chip away the rocks around several backbones they excavated in preparation for encasing them in a plaster jacket. Matt and Amy were next in line to learn this technique, and Amy couldn't wait to mix the plaster of Paris and water. The chemical change that took place when that happened was one she'd really grown to appreciate. Crystal was sitting on the ground, sketching Julian as he scraped away the last of the sandstone around the dinosaur's foot bone they had been working on. Amy was pleased to see Julian was back to being his normal self, and Dr. Forster was sitting in the shade at the far end of the plateau, happily studying the little bones with a magnifying glass. She announced that from now on she wasn't letting them out of her sight. She's going to sleep with them right next to her cot at night. Tess stood up and tugged off her safety goggles. I think it's already time for a water break, everyone, because the heat today is fierce. Matt retrieved bottles of cold water from the ice chest, and Amy was reminded of their first day of digging and the discussion of matter. It suddenly struck her how much chemistry they had all learned since. You're pretty sneaky, Tess, she said with a laugh as they all sat down under the tarp at the edge of the dig site. We came to fossil camp to learn about fossils, and you ended up teaching us about chemistry, too. Tess smiled. So you haven't minded all of my chemistry lessons? Amy shook her head. It's been really interesting, especially learning about chemical changes. I like the idea that chemical changes can turn one type of matter into another by shuffling atoms around that go on to bond in new combinations. In a way, I suppose it's a bit like recycling, Felix said thoughtfully, staring at his water bottle. What I mean is, when we recycle these plastic bottles, they'll be remade into something new. Actually, chemical changes are the ultimate recyclers, Tess replied, because they recombine the same element over and over again in different combinations that form new types of matter. A plastic water bottle already has a long history of recycling, Felix, from a chemical change point of view. Would you like to hear the story? Everyone said yes, so Tess drained the last of her water from her bottle and began. Imagine you had a time machine, and you set the dial for 300 million years ago. You stepped out into a warm, humid, green world full of forests and swamps, teeming with tall trees, gigantic ferns, and all sorts of other ancient plants. Plants and plant-like organisms grew in this ancient oceans too. All of these green glowing things, like all living things today, had bodies built mostly from compounds that contain atoms of the element carbon. Because there was so much plant life living and growing on the Earth 300 million years ago, there's also a lot of plant life dying. Some of these dead organisms decomposed rather quickly. Some were buried and fossilized like achy breaky, but some underwent different kinds of chemical changes that transformed their carbon-rich remains into the carbon-rich substances we call oil and coal. Picking up on the very top of page 60. So carbon atoms that were once in the bodies of ancient green growing things are now in coal and oil? Julian asked. Not all of them, of course, but a lot of them, Tess said. Now zoom forward in your time machine to the 1900s, when chemists started playing around with the carbon-rich compounds in oil. They discovered chemical processes that could change some of these compounds into plastics. She held up the empty water bottle. In other words, carbon atoms that were once in the bodies of 300 million year old life forms became a part of oil deep in the ground and are now a part of the plastic water bottle in my hand. Matt whispered softly and shook his head. That's absolutely amazing. Actually, everywhere you look in nature, you see the recycling of elements, thanks to chemical change. Tess reached over and plucked a braid of prairie grass from a nearby clump. Like all plants, including plants that grow 300 million years ago, this grass carries out something called photosynthesis. That's a process in which water and the gas carbon dioxide undergoes a chemical change. Carbon dioxide, that's the same gas that makes pancakes fluffy, right? Crystal asked. Yes, that's the one, Tess said. In photosynthesis, the atoms making up molecules of light and carbon dioxide are recombined, using energy from sunlight to produce molecules of sugar and oxygen gas. Plants release the oxygen into the air and use the sugar molecules to grow and build their bodies, including the parts that animals and plants eat for food. So atoms of carbon, oxygen, and other elements that were once in the air or water become part of plants and then become part of us when we eat the plants, Daria said. Exactly, Tess replied. But how did the carbon dioxide get into the air in the first place? Felix asked. Excellent question, Felix. Tess took a deep breath and let it out slowly. The cells of all living things produce carbon dioxide as a waste product. We get rid of it by exhaling. Then she gestured towards the fossil that lay on the rock beside them. When something dies, like good old achy breaky, the compounds in its body are broken down, and the atoms that are formed then are recycled. Some chemical changes that are a part of decomposition return carbon to the air as carbon dioxide. You mean that when we take a breath, we're breathing in carbon atoms from something that died? Daria asked. Tess burst out laughing. Yes, I guess you are. But atoms are no different if they are in something dead or if they are in something alive. They're just atoms. Tess glanced at her watch. One thing I'd like you to think about, and then we should get back to work. You've been working on Achy Breaky for several days now. You've gotten to know him, but think about this. When this amazing dinosaur died, the compounds that made up his body were broken down by chemical changes. The atoms that were once part of these compounds moved on. Perhaps, thanks to chemical changes, some of Achy Breaky's atoms are now a part of compounds in the soil or water or air that you are breathing. A hush fell over the group as they stared at Achy Breaky's bones, warm and shining in the bright sunlight. Amy knew she would never look at these bones in quite the same way. Felix stood up and took a deep breath. Thanks, Achy Breaky, he said. I needed that. They all burst out laughing and picked up their tools to resume their work. Before they could even get started, however, Dr. Forster came hurrying over. Her face was aglow with excitement, and she held a fossil in one hand and her magnifying glass in the other. I found something, she said, in a voice that made everyone stop what they were doing. I found unmistakable evidence that these strange little fossils are those of a small dinosaur. Come and look. They gathered around as she held up the fossils. The key was this piece, the one that went missing right away. She pointed to part of the fossil fragment. That piece is definitely from a dinosaur bone. I could tell because there are telltale ridges in the bones that are places where muscles attached in a way unique to dinosaurs. What kind of dinosaur was it? Daria asked. That's the really exciting part, Dr. Forrester replied. Based on the curve of this piece, it's from a very small dinosaur. At first I thought it might just be a baby or juvenile dinosaur, but other features that I've identified this morning are only found in skulls of dinosaurs that are fully grown. That means this dinosaur was an adult. She stopped and looked at everyone. But I've never seen an adult dinosaur with a skull this small, which means we might have just discovered a new species. I'm not absolutely positive at this point, but I'm certain enough to be very excited. Wow, a new species, Felix exclaimed. That means you could be famous, Dr. Forrester, Julian said, smiling. You told me so on my first day here. That's where you're wrong, Julian, Dr. Forrester said softly. A discovery like this means that you all will be famous. Whatever we've discovered, you've all helped discover it. And that all means you get your names on the scientific paper that will write about this little dinosaur. It'll need a name, Amy said, taking the small piece of bone from Dr. Forrester and cradling it in her hand. It'll need a scientific name, like Anchioraptor timetrion, she said, sounding out the syllables slowly. How about Fossilcampus fantasticum, said Felix gleefully. When they stopped laughing, Tess glanced at her watch again. All right, fossil workers, let's get back to work. Tonight we can sit around the fire and talk all you want about this big discovery, but don't forget, we have a bigger dinosaur to work on, with lovely bones that need to be excavated, jacketed, and transported back to camp. Amy watched as everyone picked up their tools and resumed tasks that just a few days ago had seemed strange and new. They had learned so much and gained so many skills. For Amy, fossil camp had turned out to be better than she ever had anticipated. Who knew that digging up fossil bones under the hot sun in a place with snakes would turn out to be so much fun, or that she'd discover she could use physical and chemical changes to solve a real mystery. Inspector Ellis, she thought, here I come. Now that we've finished chapter 9, we're going to start on these questions to the right. Ignore at the top where it says read chapter 13. Ours is chapter 9. Number 1. Tess says chemical changes are the ultimate recycler. Why does she use the word ultimate? So give your own definition for the word ultimate. If I say this is the ultimate recycler or this is the ultimate pizza place, what might that mean? Number 2. Plants 300 million years ago had bodies built from compounds. What are compounds? We've talked about compounds in the past. You might want to go back and look at some of your notes. Number 3. What element existed in all of these compounds? This is just comprehension. They state it in the text. What element existed in all of these plant compounds? It's just one element name. Number 4. Name the chemical changes that converted the plants into a plastic bottle. So what was the chemical change? Number 5. Which of these chemical changes happened without humans and which required humans? So which of them required us interacting with this? Remember, most of these can be found back in the chapter, so go ahead and flip back and review if you have to. Take a minute or two before we go over it. Reviewing number 1. Why does she use the word ultimate? She uses the word ultimate because chemical changes can recombine elements in lots of different ways, again and again. So ultimate usually means the best. So the best chemical changes are the best recyclers because they can combine different elements and recombine different elements over and over again in many different ways. There's just not one process. Number 2. What are these compounds that plants were made of? They're molecules with more than one element in them. So remember, a compound is a molecule with more than one element. Gold isn't a compound because it just has gold in it. Fool's gold is a compound because it has sulfur and iron. Number 3. Carbon existed in all of these compounds. Carbon. You're going to find carbon in most plants and all living material, actually. Number 4. The 2 changes are listed. Chemical changes from plants to coal or oil, so a plant becoming coal or oil, and chemical changes from coal or oil into the plastic bottle. So recycling coal or oil into the plastic bottle. Lastly, 5. Which of these required humans and which did not? The first one was natural. So plants turning into coal or oil is natural. That's actually over thousands of years as they decompose and collapse in the ground and the pressure. It's the same thing with dinosaur fossils or with natural forming oil. It's just all living matter or carbon. And the second one required humans. So coal or oil on its own obviously isn't going to turn into a plastic bottle overnight. That's a chemical process that humans use to help recycle and save the planet. We have a graph on the left and the right of these 2 processes. So on the left is the human-made one. So if you look at the very top, that's the swamp. And as time, pressure, and heat increases, that becomes coal over time. So starting at the bottom, number 1, marine plants and animals die and sink to the bottom of the seabed. The plant and animal layer gets covered with mud. Over time, more and more sediment is like sand, creates pressure and turns the dead plants and animals into oil. Lastly, oil is pushed through the rocks and forms a big reservoir or big pool. So oil naturally will form together because it's more of a liquid and will seep through. So that's how the swamps and animals at the top can become coal or oil over time, which is what we use in a lot of factories. But then how can we turn that crude oil into a plastic bottle? So when they have crude oil, if you've ever seen like a barrel of oil before that they take to the gas station, they turn that crude oil into motor fuel, like you stop and pump up in a car, and then raw materials for chemicals. So there's some byproducts to crude oil that they can't use in a car or in a fuel tank. So we use these raw chemicals and recycle them into different things like other chemical products, or we use them to create plastics. Plastic is not naturally occurring. It's a chemically created project. So we might use some of these raw and spare chemicals from oil to turn it into a plastic bottle. For our grammar page, number 1, use the word in brackets to complete the sentence, and you're going to turn it into the past perfect tense. So basically you're going to turn it into the past tense, but making sure it agrees, and it's in the perfect infinitive version. They ate the snacks that Felix blank, and your word is provides. So if you provide snacks to someone in the past, how would you end it? And then number 2 at the bottom, you're just going to pick 2 of the above examples and list the order of the actions in the space below. So you're going to rewrite them in both as a little story and put them in order. Lastly, scholars, I look forward to seeing all of you next Saturday, June 6th, at our graduation. This isn't the very last thing we're doing though. So tomorrow and Friday you have your Unit 9 assessment on Edulastic. And then on Monday and Tuesday we have Part 1 and Part 2 of our end of the year assessment. Don't worry, all 3 of these are not full test length. They're actually more like quizzes just to check progress. So don't freak out, don't panic about any of them. None of them should even take you that long. I'm still going to have videos going up to announce each of those days. In the meantime, I can't wait to see all you guys next weekend. Everyone stay safe. Reach out if you have any questions, but have a good weekend. Bye-bye.